So we're reviewing for the linear programming test part of the cumulative, all right? And on this test, you would have an X and a Y axis, and you'd have a line that would like maybe run this way, and another line that would run this way, and then they would cross. We taught you 3 ways to figure out where those lines were crossing, because there was also shading on each side of the line, and it gets kind of complicated. I'd like you to make the 2 different colored lines that I have. You don't have to use white and green, but just use 2 different colors for your lines. All right, and this green one is y equals negative 2x plus 8 and the white line, which you probably couldn't make white, but whatever color you made it, here, I'll make it blue. You could make it blue. That way our colors are the same. The blue line would be y equals negative 1/2 x plus 5. Now, if I just had to graph lines, then the only thing we could care about is where do they cross. But we also have to shade above or below them, and then there's less than signs and greater than signs. So just off to the side, would you put that sign? And I'd like you to say which one it is. A lot of people are like, well, it depends on what's on the other side of it. No, it doesn't. That's got a name. Do you know the name? So draw that sign, write down its name, and then which way, if y is on this side, which way do you shade compared to the line? I can tell you that this is the blah sign, and you shade this way on this kind. I'd like you to talk to the kid next to you about the name of this one and which way it tells you to shade. All right, that is in fact a less than or equal to sign, and it would tell me to shade under. Less than is under. All right, so we're going to do that for this green equation. We're going to make it a less than or equal to, and now that changes my graph. And shade just a little bit. Remember, my advice was don't use the highlighter and shade everywhere, because you'll have to shade forever, and then it gets really confusing about what color is mixed with what color, making some other color. If you only had 2 colors, that wouldn't be that bad, but we typically have 3 lines, maybe even 4. All right, so just shade a little bit on one side of it. All right, next thing is, a lot of kids got this point wrong. They didn't list the real world constraints. If you know what I'm talking about, list them. If you don't know what that is, you were about to get that wrong on the cumulative test. List the real world constraints. Now, in case a kid is really lost, constraints are equations. So what are the real world equations? Sam, what are the real world equations?
Y must be greater than or equal to 0, and x must be greater than or equal to 0.
Perfect. Now next, let's talk about why they have to actually be bigger than 0. Because if you're going to have real world situations like we're going to make cookies on the x-axis, and cake they both require flour. If we used up all of our flour on cake, then we can't make the cookies. If we use all of it up on the cookies, we can't make cake. Or we can make some kind of combo. Okay. So, can you have negative cake? No, that's why we have to have the y is greater than or equal to 0 and the x is greater than or equal to 0, because you can't have negative cake, can't have negative cookies. Okay, good enough on that. Now, where does the shading go for that? Take a second and shade properly, reflecting the real world constraints. It's a line. and it's shaded on one side of the line. In case you get confused, I do too. I go x-axis is y equals 0. X-axis is y equals 0. So then if I'm graphing this one, it's really like the x-axis. And I'm going to shade just a little bit above it. And the y-axis is like x equals 0, so greater than 0 means I'd shade this way. All right, watch out. Trick question. Can you see the feasible region? No, you cannot. What I'd like you to tell right now is there's 2 possible feasible regions. There's only 2 that could be the answer. Would you shade one of them in one color and the other one in a different color? And then only one of them is going to be right. There's only 2 possible feasible regions. All right. So this white one is one of the possible feasible regions. And that's if I shade under the blue line, which I haven't said yet whether it's above that or below that. Or if I shade above the blue line, then I'll make it yellow. That would be the possible feasible region. Do you get what I'm saying? All depends on whether I'm shading above or below that blue line. All right, so now I'm going to reveal that I'm going less than or equal to. So therefore, it's not this area. It's that white shaded area. All right, from here, honestly, most mistakes don't happen on what we've done. Almost everybody gets the right feasible region. They mess up the next part. They either mess up where the corners are, or they don't know how to figure out what one of the corners of it is. Or, once they do figure out the corners, they get tempted to use something that's not feasible. All right, so let's talk about why this matters. The feasible region is where you're testing like how much profit might you make. So if this is a bake sale and you're raising money for cancer research or something, and you do a bake sale and you bring it to your church, and then people buy cookies and cakes, and you make $8 on selling a cake and you make $2 on selling cookies. Can you first off write the optimization equation? You can use profit even though I haven't told you what the costs are. We'll just say that you're making $8 profit on the cakes and $2 profit on the cookies. And it's all going to charity, so you could argue it isn't even profit. But the point is, you got an equation for that, and we can call it P equals. Mr. Breen, what was that equation? 2x plus 8y. Still, almost nobody got that wrong on the test. But what they got wrong was the next part. Do you get, I told you don't even have to test 0, 0. We know we're not going to make any profit there, so by logic, no reason to test it. But tons of people aren't going to know what that point is right there. And I want to start with that one. You might be like, how am I supposed to know what that point is? I mean, I know the other end of it is the y-intercept, but like I can see the y-intercept of that green line. It's just right there. But how am I supposed to figure out what that point is right here? I know a lot of people won't know, so I don't even want to have you talk to the kid next to you because you both probably look at each other and go, I don't know. So I'd like to take a volunteer. Who would know how to find that spot? Can anybody in the room tell me? Isaac.
Is that y equals 0?
Okay, hold on a second. What are you talking about? Is that y equals 0? You mean this point right here?
Yeah.
So it's the x-intercept. So therefore the y equals 0 And therefore, if this is your equation and y equals 0, he's exactly right. Because see, the x-intercept is where y equals 0. And now, could you solve that? Yeah, you can solve that. Solve it. You'll know what that point is. Because why? Because it was the x-intercept. So you're setting y equal to 0. Feltman, when you put in y equals 0 and you solved it for x, what did x have to be? Okay. Just to clarify, we're solving this right here. We're going to go 0 equals negative 2x plus 8. And I get why you might be like, wasn't it less than? And it was. But this would be a smart time to take out your calculator. If you haven't already, why don't you take out your graphing calculator? If you want to borrow one from me, there's a bunch sitting on my desk. Negative 8 equals negative 2x. Divide both sides by negative 2. Don't you just get x equals 4? Cool. We figured it out. That point right there is x equals 4. And I can look at it, and I know, because I just said a second ago, it's the x-intercept. So y is 0. So I know, all I need to know is the x is 4. I already knew that the y was 0. So that's 4 comma 0. Cool. And 0, 0 was irrelevant, so we don't worry about that one. Do you get that the next challenge is figuring out where these two lines cross? How are you supposed to do that? Well, there's two ways that I want to talk about. The algebra way and the use your calculator way. I'd like you to take these two equations. Y equals, notice if we're trying to find where they cross, I don't care about the shading. Y equals, so therefore don't worry about the less than or equal, just equals negative 2x plus 8. And then underneath it, the other equation, which is y equals negative 1/2 x plus 5. Now, I know some people want to solve this with substitution. Some people want to solve it with elimination. And the right answer is, it depends on the problem. But in this, elimination's way quicker. It really is. If you haven't learned elimination well, you should use elimination on this one. And you just go, add them straight down, but nothing cancels. So you got to do something first. Talk to the kid next to you. If you're going to add these straight down, what do you do first? I'm going to pause while you talk to that kid. So this student told me, multiply the bottom one by negative 4. And that's not what I did last hour, but I like it. This will work. Because this, timesing by negative 4, will make it cancel with the top. Because this one comes out to positive 2x, and this is negative 2x, and they'll cancel each other. Now, here's the problem with this method. You've got to multiply everything by negative 4, including the 5. It's really, really common for people to think, wait, only multiply it on one side, so it's only once on that side. No, you have to distribute it. You really do. It has to be multiplied here and here. All three parts need to be multiplied by negative 4. It's true. I can prove it to you. If you had 1 plus 6, it equals 7. If you just try to multiply this side by 2 and this side by 2, it'll say 2 plus 6 equals 14. That can't be right. You have to multiply all three parts by 2. 12 plus the 2 does make 14. Okay, so moral of the story, you have to multiply all three parts. So now, watch how quick this solves. That's negative 3y. This part's gone. Negative 20 and the 8 makes negative 12. Y equals 4. See how that was pretty quick? All right, I solved it. Y equals 4. Wait a minute. That point right there is y equals 4? It is. I just don't know what the x is. But y equals 4. See? From right here. I solved it with algebra. You have to be able to do that. All right, Henry, what do I do to get the other part of the point? If y equals 4, what's x?
You set y to 4.
Yeah, I'm going to go up here, put in a 4. And then I got 4 equals negative 2x plus 8. And then, can you solve it for me quick? What is it?
I had x equals 2.
You guys agree? X equals positive 2? All right, good. Everybody's agreeing. This point is 2 comma 4. Now, there is a faster way with technology. So, I'd like you to put in these two equations. Focus on the yellow equations. I'm going to erase this stuff we did to the equations. And make sure, because honestly, you're going to use this on the cumulative test. You're going to have to know where two lines cross with a calculator. Type them both in. Make sure you remember where it is on the calculator. It's right above trace, but you're going to find calculate the intersect. There's a button. Didn't tell anybody where it was. I did it in class twice though, so. Just try all the buttons. All right. Now, there's two kinds of kids right now. Well, three kinds. In one case, they haven't typed in the equations yet. Okay, hurry up, type them in. I'm going to walk around and see everybody's, so you're not going to get away with not doing it, so we'll do it. And then, you got to do this with the second calculate intersect. If you're using the trace button, you might think you're like, this works perfectly fine. It won't, because on trace, it only works when they're nice whole numbers. When they're weird decimals, trace will not get you to where they cross. You have to learn the thing that's above trace, second calculate intersect. And the way you can tell is at the bottom of your screen, it will say intersection, and then it tells you where the intersection point is. So, I just need you to show me that the bottom of your screen says intersection, because then I know you know how to do that. Yay. Yay. Intersection, 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 intersection. Pause for a second while I roam the rest of the room doing that. I just checked and everybody knew how to find where they intersect, which was 2 comma 4. Cool. All right, so then the question becomes, what's this last intersection spot right here? If you understand that that's the y-intercept of this equation, then it's just staring you in the face. Aiden, do you know what it is?
Yeah.
What is it?
0.5.
It's 5, because the y-intercept sits right there in the equation. That one's a really easy one. Now, if that's 2 comma 4 for this spot, and this spot is 0 comma 5, and this spot was 4 comma 0, what makes you the most profit? Now, one of the rules on this is you have to compare at least the top two. And I wouldn't know, if I was a kid, which was the top two, so I would check all three of those points. But if you only have one answer, you were just guessing that this one makes the most profit. Even if you're a good guesser, I'm not giving you credit unless you compare at least two of the points. And I really want you to do all three because I think you're going to maybe guess wrong. So I got 3 points, 0, 5, 4, 0, and 2, 4. 0, 5, 4, 0, and 2, 4. These are all what's called ordered pairs, and they're in amounts of cookies and cakes. And I could theorize what I think will give me the most profit, but still you got to show me. And you use this profit equation up here. P equals 2x plus 8y. So I'm going to put it all in one spot. And I'll be looking for this area on your test. All right. Aiden C, can you tell me what the three numbers are?
40.
40, was that for the first one here?
Yeah.
40 for this one, okay, good.
8.
Yep,
And then 36.
yep. And turns out the real world best profit is that. But I could totally see the argument for saying, but we're going to want to make both. Just to add variety, we'll have cookies and cakes for sale because it's more interesting. But if you want to just make the most profit, this would make the most profit. Cool. All right. That's going through pretty much. Oh, here's another really, really common mistake. I don't know if I mentioned it or not. But you know how we were looking for the most profit? Some kids logically were thinking, well, cake makes you the most money. So I want a lot of cake. And they go up to this point right here. And they go, that point makes even more profit. Why can't you use that one, Aiden? This would make more profit.
It's not in the
It starts with an F.
feasible region.
There it is. It's not in the feasible region. So I had to mark that wrong a bajillion times because it's a place where things cross, but it's not on the edge of the feasible region, so it's not feasible, meaning you can't make that much cake. Like it might be we don't have enough flour. Okay, so moral of the story. We've now covered everything that would be really important for the linear programming, and if we go look at the homework, it's a mix of linear programming and matrices. So all you'd have to do tonight is problems 1 and 2. But that leaves you a lot of homework for tomorrow night. So be nice to tomorrow you and do more than just 1 and 2 because then you'd have to do the whole rest of the assignment with just 2 more pages of stuff. So if I were you, I'd do 1 and 2 and at least number 3, which will be delving into matrices. But hey, you're good at matrices. You already got tested on them. It's fresh in your mind. All right. So that's your job for the next few minutes. I'm going to finish up by giving you your tests back. And the actual smartest thing you could do right now would be to take those tests and start the corrections process on it. Because we have a healthy amount of work time today, like 20 minutes. That means you can walk up and get help. Like, hey, can you explain what I did wrong on number 4 here? All right. So some of you will want to do corrections, even though there was a lot of A's. There's probably at least 4 or 5 of you who should be doing corrections so that your cumulative can bring your grade back up. That's all I got for you for today.